Okay, so let's take a look at a couple practice problems where we're going to use substitution to solve a system of equations. So this first one, this is from a problem we did a couple weeks ago when we were looking at Edna and Maria and they were hiking. And what we did was we graphed both of these equations and then found where the intersection was and found that that was a solution. So we solved this system of equations by graphing. We solved it graphically. This time we are going to solve the equation by using substitution. So what we do is, so we see that d equals 1.5t, and then d also equals 12 minus 2.5t. Those are two different graphs. We want to find where they meet, what the solution is for both of those equations. So we can plug 1.5t. We can plug that in for d down here. So we get 1.5t equals 12 minus 2.5t. Now I need to solve this equation for t. That means I want to get the t all by itself. So I'm going to move this 2.5t over here to be with the 1.5t. Since I'm subtracting on this side, the way I undo that operation, I use the inverse operation. So I add 2.5t over here, which means I also need to add 2.5t over there. So the negative 2.5t and the positive 2.5t cancel out, and I'm left with just 12. And then over on this side, I have 1.5t and 2.5t. I can add those together since they're like terms, and what I get is 4t. Now, there is an invisible multiplication sign in between the 4 and the t, and so I know that in order to undo that operation, I have to use the inverse of multiplication, which is division. So divide this side by 4, divide this side by 4. These 4's cancel out, and I'm left with just t equals 12 over 4. 12 divided by 4 gives me 3, so t equals 3. And what I want to do is I want to plug these in. I get to choose which equation I want to plug that into. It doesn't matter which one. But I'm going to plug it into that first one because it's a little easier. So I plug that in up here for t. So I get d equals 1.5 times 3, which equals 4.5. Therefore, where they met, where those two solutions intersect, or where those two equations intersect, the solution to the equations is going to be at time equal to 3, and then distance equal to 4.5. Let's do two more. These ones are not really based on a real-world problem. They're just purely math, but works the same exact way. So what we're going to do, I have two equations here. Both of them are set equal to y. So what I can do is I can plug this piece in to here. I can plug it in for y. So what I get is 25 plus 30x equals 15 plus 32x. So now I want to get my terms with the variables on one side of the equal sign and my terms that are constant to the other side of the equal sign. So first I'm going to move this 32x so it can be with his friend the 30x. So if I'm adding 32x, the way that I undo that operation, the way that I move that term, is I need to subtract 32x. And if I subtract 32x over here, that means I have to subtract 32x over here. So I'm left with 25, and then 30x minus 32x would give me negative 2x. and that's equal to 15. These guys cancel out, all right? And now what I'm left with is 25 minus 2x equals 15. Again, I want to move this 25 so it can be with his friend, the 15. So I subtract 25 over here, which means I also subtract 25 over there, which leaves me with this guy. Those guys cancel out. I'm left with just negative 2x equals 15 minus 25 would give me negative 10. Now, again, I have an invisible multiplication sign in between that negative 2 and the x, so I know I need to divide by negative 2, which means I also divide this side by negative 2, and I'm left with x equals negative 10 divided by negative 2, which gives me 5. And now I have to solve for y. So what I do is I take that x equals 5 and I plug it in. I'll plug it into that first equation. So I get then y equals 25 plus 30, 30x, but again I'm plugging in x for 5, I mean 5 for x, you know what I mean, 30, so I get 30 times 5, which leaves me with y equals 25 plus 30 times 5 is 150. So y equals 175. And that's my solution to the equation would be 5175. So we can check that pretty easily. So I'll check it in my first equation. So I'd get, so again, this is my x coordinate. This is my x coordinate. This is my y coordinate. First, I'll plug it into this one. So I'd get 175 equals 25 plus 30 times 5. So 175 equals, again, 25 plus 150. Yes, that's true. And then we'll plug them into the second equation. So I get 175 equals 15 plus 32 times 5. So 175 equals 15 plus 32 times 5 is 160. And yes, that is also true. So I know that this is in fact the solution to the system of equations. Let's do one more example. So I have y equals 14 plus 7x and y equals 11 plus 4x. First thing I'm going to do is I'm going to take this and plug it in for y. Because again, y equals this. Okay, so I get 14 plus 7x equals 11 plus 4x. Now I need to move my terms around. So I'm actually going to move my 4x to be over here with the 7x, and I'll move the 14 to be over here with the 11. Let's move the 4x first. Since we're adding 4x, I need to do the opposite. I need to do the inverse. So that's minus 4x. And if I do that to this side, I also have to do it to this side. So I get 14, then 7 minus 4x is 3x, and that's equal to 11, and then this 4x and the negative 4x cancel out. Now I'm left with 14 plus 3x equals 11. I'm going to move my 14 to be over here with the 11, so I need to, since this is a positive 14, I'm going to subtract 14. And then I do that to the other side. So I get 14 minus 14 equals 0. So that cancels out. And I'm left with just 3x equals 11 minus 14. 11 minus 14 is negative 3. Again, there's this invisible multiplication sign in between the 3 and the x. So I know to undo it, I have to do the inverse of multiplication, which is division. So I divide by 3. And what I do to this side, I have to do to the other. So I get divide by 3. And I'm left with, those 3's cancel out, I'm left with just 3 equals negative 3 over 3, which is equal to negative 1. Now what I want to do is I want to take that negative 1 and plug it in for x up here. So I'm going to use that first equation where it says y equals 14 plus 7x. But I'm going to plug that negative 1 in for x. So I get y equals 14 plus 7 times negative 1. That simplifies y equals 14. 7 times negative 1 is negative 7. So plus negative 7. 14 plus negative 7 gives me 7. So my solution, my proposed solution would be negative 1, 7. Let's try plugging those into those two equations to double check our work. So I plug negative 1 in for x and 7 in for y. Let's look at the first equation. So I'd get 7 equals 14 plus 7 times negative 1. 7 equals 14 plus negative 7. Yes, that's true. 14 and negative 7 do equal 7. Now let's do the second equation. Plug in 7 for y, negative 1 for x. So I get 7 equals 11 plus 4 times negative 1. That simplifies to 7 equals 11 plus 4 times negative 1 is negative 4. And yes, again, that's true. 11 plus negative 4 does equal 7. So I know that's a solution to the system of equations. Right, I'm going to post some practice problems for you to do. I hope these are helpful while you're working.